Good day, folks. This is tutorial number 25 in a playlist which deals with the kinematic scenario in 3D Experiences Release 2025X. Remember, there are two playlists. One of them is called kinematic scenarios and the other one is dynamic scenario So the one that I'm making right now goes into the kinematics one. Now, I want to talk about the kinematics excitation recorder. And basically, that allows you to make a cartoon without any physics in it. And just about, most of the stuff that you see on TV and videos on YouTube and other places is there's no physics in it. It's just that the animation is done by just moving things and recording shots and then playing it back at you, which may be perfectly okay, but and that's the purpose of this tutorial. Now, this is a good complement. A good complement to this tutorial, or the other way around, is what you see down here by that gentleman. So, to make things easy, what I'm going to do is explain it in terms of a system that has 4 degrees of freedom. So there are 4 revolutes, 3 revolutes, and then a prismatic joint. Now, I'm not going to make the parts here, but I will move them apart so that we can actually go ahead and create the joint and then proceed with the rest of the problem. Okay, so this mechanism that we create is going to have 4 degrees of freedom, as these 4 sliding bars will indicate you after we go through the process. So let's go ahead and actually to 3D experience, and the model is already made, but there are no assembly constraints here, and there are no joints. Okay, so first thing I'm going to do is to fix this track or base. So fix that base. It is fixed. Then I'm going to create my prismatic joint where this block can travel along that base. So we have a prismatic under the engineering connection, and there are different ways of doing it. So what I'm going to do is I will use, for example, uh, uh, really doesn't matter. I'll use that's my favorite one. Number 8. Okay, so that edge and that edge are coincident. This plane and that plane are coincident. And for controlling the distance, my degree of freedom is going to go measuring from here to that plane. Okay, so right now it's 133 millimeter. That's fine. Okay, so we created our prismatic joint. You can see that. Then I'm going to do a revolute by putting this block on top of that. I will use this. Let me see. No, this is a prismatic. Sorry, cancel that. Let me use a revolute right there. And I use my favorite one is this fourth template here. Edge, in principle, axis and axis, plane and plane, coincident, and then angle between 2 planes. So I'll use this one. The only thing I noticed that I can't always pick the axis. Like here I can, no problem. And for example, we can do, for revolute, I do this plane and the plane underneath it. Okay. And for measuring angle, I can use this angle, the angle between these 2 planes. And then we say okay. And if you update, it's going to go where it's supposed to. Then I'm going to mount this link on that as a revolute. So it's going to be another revolute. I'm going to select, once again, I use this 4th one. So I use this axis and that axis. Okay. And I use this plane and that plane. Okay. Well, actually, I just noticed that I would have liked to pick the top one. So actually, let me see for a second. This axis and that axis. Okay, let me clear the selection, and use instead that axis. Okay, very good. And then for angle, I can do, for example, the angle between any vertical plane of this and one of these faces, or oh sorry, this face For example, let's go to the link one. I use the, let me see, is this vertical plane? Yep, it's right there. This, and for example, that plane. Right now there is 0 degrees, which is fine. Finally, I mount this on that as a revolute. So for the template, this axis and that axis, this plane and that plane. And once again, any two vertical planes. Or you can also do horizontal one, it doesn't matter in this case. Yep. Okay, so basically we have assembled these things and there are three revolutes and one prismatic. Let me update this thing and save everything. Okay, so in fact, if you go and we're done here, but let's move on. So we go to 3D. We go to 3D experiences. This compass on the top side. Choose application, mechanical systems design, and you create your mechanism representation. And if you check the manager, it says that there is one prismatic, three revolutes, and then the degree of freedom obviously is 4. Now, if you click on this icon, it allows you to move things the way manually. You can see that. For example, here, yeah, reset everything, and we go back. Good. So we're done here. Now we're going to go to mechanical systems experience, where we can create our scenario. Okay, so what we're doing is using this kinematic excitation recorder. You click on it, and as soon as you do that, this dialog box shows up, which says kinematic scenario 1 is being created. The duration, for some reason, they have a. These are not real times. These are basically the steps. So as I pointed out, these are not real time. These are steps that I can, it's under my discretion. The only thing is that, let me change this thing to 10. I'll leave time step as 1 and I'll talk about this thing later on. Now, as soon as you say OK, notice that excitation scenario has been created. If you double click on it, I can put the stuff in it. Now there's two options, doing automatically or manually. Automatic, when you select it, every time you drag one of these sliding bar, it's recorded. But I don't want to do that, I want to do that manually. For example, and although it's not necessary, but I did put a 10. Remember I changed 100 to 10? Because what I intend to do is to 10 movements in and record them. It doesn't have to be 10. It can be more or it can be less. But anyway, so let's do the following. My first one is this position, which I'm going to just click on record. So this is the default position, okay? Which I really didn't have to do that, by the way. So let me move this thing. All right. And when it gets there, I can record it, but then I can do other motions and then at the same time record it. For example, let me turn this thing and then move this arm up and now record. Okay, so another one. This is 2, right? So let's move this thing, move the other arm up. And turn this thing and bring this thing, well, okay, record it. And now let's bring the link 2 down, record it, move the block and turn the upper block recorded. I'm at 5, so let's do a couple more. This, that, that, record. Another one, fooling around with this fellow. Record, you're down to 7. Let me turn this and move this thing back. Record. And let me put these things to position 0. Okay, record. And the last one, what I'm going to do is I will just turn this entire arm around and straighten it up, straighten it out, and record. So basically I've reached my 10. All right, now notice that I can play these things, there's no problem, but let me say okay to show you what happened. So recorder has been created. If you double click on it, you can play it one by one. So here is how you advance by step. These are all the things that I did, and I put it in a step. Okay, now you can also kind of slow it down a little bit, change this thing a couple of times. Initially it was 1, then it became 0.1, then it became 0.01. So let's see if it's smooth enough. Maybe I put it back to reset 0.1. Let me put it 0.1 and see how it is now. Yeah, and you can play it. Okay, good. And when you're done, you say okay. All right. Now, notice that let me show you here. This has been created, but I have not actually run it. So, and I'll tell you why we need to run it if you want to do some other stuff with it. So if you put the cursor there, right click, force compute and generate results either here or you do it from there. Okay, so let me go ahead. Good. So we have run the simulation. We have run this kinematic scenario, and results have been created, and I can go actually and click on the play results, and we can play it. See if we can slow it down. Slow it down again. Rewind. Okay, let's play it now. I rewound it so it's not at 0. Okay, slow it down. Rewind it. Play at 0. Okay. Now it looks like slowing it down from here does not affect this. Okay, so if you rewind it and then play it, that doesn't seem to have an effect here, but that's okay. But now why did I do this? Because notice that once I create the results, there's this icon over here called export animation. Export animation. So actually, let me go back here to my slides. We did this, we did that, and then I ran it. See that force compute results. Results have been generated, and there's the export animation. Okay, so export animation. So when I go there and I click on that, first of all, when I click on that, notice that it says results have been successfully exported. Now, exported does not mean that this is going to be gone to an API file or something like that. Look what happened. Under the assembly, an animation branch has been created, and if you double click on this is in the assembly. So even if you only have the assembly later on, you save the result, only have an assembly, this is going to be there, and you can play it. For example, double click on this. See now? Double click on it. Yep. Okay. So you can play it. Now, even if you slow it down, it doesn't have much of an effect there. It still, unfortunately goes very fast. Okay, so notice that the purpose of that export animation running or simulating and it was creating that icon which says export animation, which means that it's going to be uh, in your assembly file. Now, if you want to create an AVI file, once you are here, okay, you can click on this option, and you can click on the second item from the left tab from the top, animation, record a movie. If you want to put it in a check the format, for example, this is the only format that I have. That's okay. We can't do much about it. Now notice that here you go and play it forward. Here's the slide that goes with it. Notice that when I double click on this thing popped up, and then I say, let's go to the next slide. You go to the option. This is the last tab, and play it. This is the next thing. Record movie, play it. And then when you do that, let me go back here. Play it. Needs to start it. Apologies for inconvenience. Excuse me. Oh, it crashed. Yike. Okay, as you notice, this thing crashed on me, and unfortunately I had not saved everything. So let me go and start where I left off. So here was the recorded excitation, and then I'm going to run it. Okay. And what that does is that it allows you to export the animation. You click on it. All right. Good. Now, what does that do? In the assembly, this is the assembly, it puts an animation file that you can click on it and play it anytime. Now, even this, if this application is not open, it puts this thing in your assembly. Let me show you, for example. Just give it a minute. You can notice that it did play. Okay. And but let me go back here, back to the results. You already saw that, so we go back to the scenario. Okay, go back to results. Okay, so I did export the animation, right? And let me play it again. Okay, where is the player here? Right here is the player. Okay, notice that you're in assembly. You can play this. Okay, and on the right here, see that under options, you click on this, and second icon on the left, record movie. You can't change the format because that's what it is, the only format that we have. And then what you do is you play it. Notice that you have to play. So what am I talking about? Right here. Right here. You check that, and then you play it. Okay, so let me go ahead there and play. Good. And notice that what it does, it says, where do you want to put this AVI file that was created? See, where do you want to put the AVI file? And you go put it in the spot that you want, but click on the file. I'm going to put it on my desktop, and I'm going to call it January 6th video. Okay, and then say okay. And okay. All right, let's go check it out. On my desktop, there is a folder, there is a file called January 6th video that is created, and it shows you the animation, but in the form of a AVI file that you can use it for whatever purpose that you've got in mind. I have to be honest with you, some of these things that are in there, including the time and frame rate and things like that, you just have to, it's not well documented, but you just have to play with it until you get what you like. All right, folks? So good luck. You can make a cartoon now without any physics.